Okay, now we have Martin from Picnic. He's going to talk about multimodal product demand forecasting. So basically how your food gets to your house from the internet. Let's give a warm welcome to Martin.
Good morning, everybody. Bringing food from the internet to your house. That's a very good description of what we do. Maybe to start who I am. So my name is Maarten. I'm working at Picnic Technologies as a data scientist, where I mostly work on demand forecasting of articles at a large scale. And I'm also a researcher at the University of Amsterdam, where I work with multimodal machine learning. So maybe the topic of this talk might not come as a surprise, telling my background. It's the multimodal product demand forecasting. So what that exactly is, I will explain later. But basically, using the pixels on your screen to better predict the demand of our articles, which might seem a bit far-fetched, and it is, but it actually works. So that's already a small sneak peek to the end of the presentation. So what you will be learning today is, well, how we do article demand forecasting at Picnic, which is quite interesting. But also, for everybody, in the corner there is EPV, and what that stands for, you might hear later or have to find out yourself. And you can win a Lego version of that if you go there. And I also will be encouraging you all to do groceries at Picnic. Because who's already doing their groceries with Picnic? And who's not? Boo. I will convince you. And last but not least, I will be teaching you how you can use a picture and a description of a potato to make better demand forecasts. And hopefully that will be also interesting for other types of tasks as well. So what does Picnic do? For everybody that's not yet a customer, we bring groceries to your doorstep for free, whilst being sustainable and reducing waste. So make sure to sign up, because that's all, I think, pretty nice things. And how we do this is basically, well, we don't have any brick-and-mortar stores, because we need those. We actually, straight from the farm, try to bring the products as fast as possible to your house using these vehicles. So if we have a potato, it goes from the farmland to your house as fast as possible. This was the only animation I put in the slides, so I hope you enjoyed. The nice thing about working at Picnic is, it's also a bit of a recruitment talk, of course, is that we build everything in-house. So the software, the app, of course, because the app is the only interface we have with our customers, except from the runners bringing stuff to your house. But also the hardware. So even the vehicles we design ourselves in-house, so we go pretty far with that. But of course, as a data scientist, we also build the algorithms in-house, and we have quite a lot of them, actually. So of course, we have the product recommendations in the app, making sure that people can find the things they want to buy quickly. We have customer success models, so that's a lot of NLP, trying to get the questions to the right people as fast as possible. We have a lot of routing, since we have vehicles that have to go to houses. Well, you can figure that one out, I guess. It's very important to do correctly. And today we're going to talk more in the supply chain corner, so that's the article demand forecasting. But of course, we do a lot of forecasting because it's very important for us to know what's coming up. And I think we have about 26 models running in production supporting our whole operation. That's important if you want to win the Lego EPV, by the way. But today we're going to be talking about article demand forecasting. So you see these nice products that we sell. Basically, the article demand forecasting is for, well, months ahead, days ahead, predicting how much of these we were going to be selling. And for some products, it's quite easy, because people with us, we don't deliver within 10 minutes. We actually deliver the next day. So if you decide to sign up for Picnic, which I can truly encourage you to do so, you can order bread for tomorrow. And, well, the moment we start baking it, we already know how much we have to make. So that's a quite easy task if you're a data scientist, because we already know what we have to do. But there's also products that we don't bake ourselves, because it's pretty hard to bake a melon. So we get them from suppliers. So we need to know a few weeks in advance, like how much we're going to be ordering. If there's a promotion, maybe we need to order a lot more than normal. So we really need to get that correct. And I might say this is one of the most healthy slides you will see today, if I'm maybe right. But for some products, we also have like a constant feed, like a real-time rolling forecast with how much products we'll be selling that's sent to our suppliers. So they can, on their side, they can, well, basically optimize their operations. So here you can see 4 mangoes. And then I accidentally left this slice in from karaoke night. Who gets the reference? A few people, I see. Okay, back to the serious part. So the accurate forecasting that we do is essential to balance waste and unavailability. If we forecast too much, we have waste. This is something we really, is at the core of our company, to prevent. But at the same time, if we forecast too little, we will have unavailability, and our customers will maybe go somewhere else for their products because we don't have them. So that's very bad. We have to be very good at forecasting, and this is why we go pretty far with that. So next up, I have 6 potatoes and 7 facts about article demand forecasting at Picnic. I will go through them quickly, but to give a bit of a setup why we went into the whole multimodal part of it. We use Snowflake as our data warehouse, basically, which is very nice. We have about 15 data engineers working on that non-stop to get us very high quality of data, almost real time even. We have a team of 12 data scientists, what we call full stack data scientists, so actually with a software engineering and more mathematical background. Over 150 analysts that really help us out with finding the right features, etc., things like this. Some of them even build models themselves. We have one of them here today. And we have hundreds of operators that are, for example, in the inbound system that we have adjusting predictions to see if they're correct. So yeah, sort of the human in the loop part of it. So we're active in 3 markets right now: France, Germany, and the Netherlands. We skipped Belgium, but I did a little bit of slide magic to hide that fact. So for all these markets, we have about 10,000 articles, give or take, which we are trying to order fully automatically, but also have humans in the loop. So these are these operators. So this amounts to hundreds of millions of predictions every day, with a variety of models and decision logic all combined together. Yeah, so this is a bit of an overview. I will get back to that later. And yeah, we serve this all on Kubernetes, and we have Argo to set our jobs up. So depending on the type of model, the freshness of the model, we can all really orchestrate it really nicely. And the nice thing about, you also see the Picnic logo here, this is because we have a lot of in-house Python packages that we use, from things like connecting to your database to also even like model performance monitor tools that we made in-house. And another nice thing that we have is automatic retraining with GPU-enabled Kubernetes nodes, which is very nice, because we can just schedule retraining as much as we want, and it will all scale, yeah, until we basically spend way too much money. We also have Pandera, which I can really recommend to look into for data sanity checks. It really helped us a lot. So really use that if you want to find issues before the issues find you. MLflow, also very nice to keep a nice structured way of logging all your model training runs. Yeah, NVIDIA and PyTorch, I think at this venue do not really need an explanation, but we do use them. Other things we use for the continuous alerting is Datadog, which is more on the server side, but also very nice to know when your models are not running anymore, because no prediction is often even worse than a bad prediction. And everything is always linked to Slack, which is very nice, because then we can actually, send messages forward to people like, hey, the model trained very well this week. You can click here to a dashboard for more insights, etc. So, very quickly, some facts. So I'm not going to be talking about all the models that we have. I'm going to be zooming into one particular model that we're using, and that's the Temporal Fusion Transformer. My colleague Sharon last year gave a talk about this one, so you can look that up. I can really recommend that if you want to know more about the nitty-gritty details of it. But basically, it's a very nice model made by Google with a nice implementation. Well, nice. It's an implementation in PyTorch forecasting. And it's very versatile. There's a lot of different type of features you can put in there, and it's very good at a lot of forecasting tasks. So, of course, one of the things we put in there is tabular input. So you can think about product categories, holidays, historical demand, vacation periods, the weather, promotion, recipes. Well, it's all very important, works very well, but there is an issue if you use only this type of information. And it's a picture of Pluto, because I'm talking about the data drift and the changing of categories. I'm not going to explain the reference, but I think it speaks for itself. What happens with our products is that they move around in categories a lot. For example, if you have a nice steak, normally it would be considered meat. During Christmas, it's like a nice Christmas article. It moves around in the data, which you can, of course, adjust for, but there's always weird things that will happen with these type of categories in tabular data that in your test setup will work perfectly fine, but the moment you go to production, they change a lot, and, well, there will be all sorts of drift happening. And then we also have the cold start problem. Since we constantly are expanding into new markets and launching new assortments, well, we don't have any historical demand, so good luck with your forecasting. And also the world changes. As we all might know, during COVID, etc., that this is ongoing. We don't know what's going to happen next, but it's hard to train for it. So recently, the new power of transformers has been unleashed on us. I used this picture at the beginning. I think it's me, but then slightly more presidential. It's a completely synthetic picture. These we all know, the Pope in the puffer jacket. And this is also a generated tree on a website I made, generatedtreeforfree.com. It does nothing, but when you go there, it will generate a fake tree. These are all very nice and fun. But we were thinking, can't we use transformers for a more sustainable planet? So it really aligns with the keynote this morning. And I think it's possible. And why not take it a step further and take pictures of a potato to make a more sustainable planet, which is actually possible. So if you think of it, because all the decisions that our customers made are in their brain and based on what we serve them in our application, these are just pictures of products and descriptions of products, and they use this to decide if they want something, so predicting the demand that we want to predict as well. So would it not be possible, based on a picture, to think, hey, where is this going to sell and how much is this going to sell? So an example of this is, for example, can of Bavaria. This is probably going to be easier for Dutch people. You can sort of assess where in the country this is going to sell, and that is going to sell a lot during Carnival, for example. Something like Grols is going to sell a lot in a different part of the country, and a lot during Zwarte Cross, for who gets the reference. This will really kick off. And this is, yeah, well, probably will sell a lot in Amsterdam, and in Rotterdam it will be less popular. Can recommend the beer, it's a very local product. And this is all just based on the images, so let alone if you add the text. So this is not based on our customer data, this is a bit my gut feeling. This is our areas where the products will sell more. So combining this all, this is what brings us to the multimodal temporal fusion transformer. Basically, we're fusing this all together to make better predictions. So the past input I already talked about. Then we have the future known inputs. So this is like weather forecast or the confirmed demand we already have. These go into the model. But what I will be zooming in now is like how do we extract visual and textual features to also feed them into this forecasting model. Starting with the textual embedding. Yeah, using the stillbird. So it's already a bit old school, but I think it's still a very nice model for techniques like this. Basically, what we did here is add an additional layer on the end, make it linear, so we can basically extract embeddings from it. And then we trained them on product text like this. So you see, for example, the pumpkin cubes, where in the text you can already see some hints, like in what season, what events might it sell. So I was thinking if you can get that into an embedding, it will help the forecast. So this is a translation, by the way, because there is some typos in it, probably GPT or something. It was GPT. But the information is in there. So what we did here is train the stillbird model with some frozen layers on these texts with the text descriptions and ingredients as input, and have like the average demand for a product as the target of it. And like that, we sort of like fine-tuned the model for this particular task. Can be done in a lot of different ways, but I would say this was how we tried it for this experiment. And then we also have the visual embedding. For that, we would use the ResNet, which is, I think, almost historical, but very, well, you know what you get, and it works how you want. Basically, we did the same thing there. So we gave product images as input, and we had a last layer with like a lot of reduced dimensionality, going from about 2000 to about 30 in size, and fine-tuned it on the average demand per product as well to be able to turn these pictures into an embedding. And, well, we do some, I would say, more categorical type of geographical features as well. But in order to also really combine the geographical aspect of these products demand with the nice fancy features from the visual and textual side. We also used the geographical embedding, for which we create a graph. So the purple square blocks you see, those are like the warehouses the granularity that we're predicting demand for. And the green ones are all the hubs. And this is only a few of them, because else the picture got very cluttered, but to get a bit of an idea. We turn that into a graph, and using Node2Vec, which you can look up, is a very nice model to just turn any graph into some sort of embedding. We actually get some of like a geographical embedding, which will allow to very precisely understand like in what type of areas will they be delivered. So yeah, then we're going to the nice part, the evaluation of this all. So we're predicting at a very low granularity, especially I think after the talk before, this is nice to mention. So it's for all our articles, for all warehouses, for specific days and specific slot picking groups. So when talking about evaluation, I always like to mention evaluation metrics are like sheep. They're happiest in large groups, so I would always advise on using as much as possible and showing as much as possible. And also use them on different subsets so you can really see what's happening here. But that's my advice. Now from the next pictures, the table I will go into using WAPE only, so I'm throwing my own advice away. And also with evaluation, of course, it's good to also just look at your predictions and actuals, like at the lowest possible level, what we do here. So for the pumpkin cubes mentioned earlier, you can see all the different, well, it's like combinations of these models. So I'm not sure if you can see it here, but the purple line is the text and the geo multimodal temporal fusion transformer. And here you don't really see the improvement, but overall there is actually. So looking at WAPE, adding this type of multimodal features, it really puts a dent into the predictions we make. And these experiments were done on a very small data set, with only 50 million rows or something. You could see a big improvement. And the improvement seems to be even more the further ahead we predict, which makes sense because, well, for the next few days, we already have a lot of confirmed demand. So the model tends to behave quite differently. And what is fun is when you take like different subsets, so that's advice I am following myself. You can see that for some categories, like adding the geo information really works well, and adding the text might even decrease performance a bit. So it does show that we still need to do a lot of tweaking to the model, which I think is still possible. But overall, adding different type of modalities really can improve the forecasting task. And this is, I think, nice. It's the WAPE, some people say, per delivery date during Christmas 2022. And where you can really see the 25, 26, so the first and second day of Christmas, you can see it puts a really big dent. And this is, I believe personally, because of how many categories change there, etc. But that's also one of our most busy days, so this really makes people on our business side very happy to see when we can improve the model there. So, I hope you learned how to use pictures of a potato and descriptions of a potato to achieve more stable predictions. Maybe it inspires you to also look into more multimodal approaches for other type of projects. Also want to mention we have some very nice discounts this week. So beers, the second one, 50% off, and also for your breakfast cereal as well. So before and after your PyData conference, you can come to us. And of course, we are hiring. We're hiring a lot, Python developers, data engineers, data scientists, and ML ops engineers. You want to know why we use these different names, come visit us at the booth in the corner, please. And you can also win this very cute custom electric picnic vehicle, which is also an answer for one of the quiz questions, I believe. If you want to learn more about what I've been talking about, you can check our blog, where we write in more detail. And there's also a preprint available on this on archive. And yeah, that's what I wanted to share with you today. Yeah.